Hello, everyone. Thank you for attending so late in the day. I know everybody is probably incredibly fatigued at this point, so I'm glad you're staying on for the show. I'll be presenting a community update for OCP Solutions Technical Committee. So this is going to be an overview of all the activities over multiple work streams. Something to note is that some of the work streams within our OCP Solutions Technical Committees did have standalone presentations at the OCP Summit. They're at major milestones, and so they have a full session all to themselves. For that content, what I would recommend is that you actually view their standalone presentation, where you'll get a lot more rich information. I'll be presenting some highlights of two specific work streams along the way. One is requirements, and one is FMEA. The other work streams, the hardware management work stream, the total cost of ownership work stream, and the power distribution work stream all had standalone sessions. So I'll do a brief update at the end for them. But anybody that's catching up on YouTube later, anybody in the room here, those sessions will be best for you to attend. All right, with that, Immersion Solutions Technical Committee is one of 4 technical committees within our immersion community. It complements the work that the fluids community is doing, the reliability community, and the IT equipment community. It's comprised of several different independent work streams. We're all focused really at the systems and integration level. I kind of describe this as the final mile style of work stream. How do all of these pieces connect with one another? It's not focused on a specific component, but it's focused on enablement. So how do you justify the business rationale, the TCO, the return on investment to adapt and adopt new technologies? How do you design different styles of equipment to fit into this immersion system? How do you ensure interoperability? And how do you prevent failure and other risk scenarios? So my fellow workstream leads are on this slide. They're also in this room. So at the end of the session, I'll ask them to stand up. We might have some time for Q&A as well. The first work stream I'm going to update on here is Immersion Requirements. Immersion Requirements is kind of the foundational layer of guidance that the immersion community puts out to its members. It sets the baseline, really, for what is the minimum that we have to do at a component level in order to ensure performance and safety and function of the equipment. So there are 2 key activities that have been ongoing throughout the year for Immersion Requirements that I wanted to highlight. The first one is the revision of the existing Immersion Requirements document. This current version is revision 2.1, and what we're doing is we're overhauling certain aspects of it. We recognize that innovation is going to continue, and we need to evolve our guidance and our standards alongside it. So there's some activities there. The other really important thing that we're doing is we're facilitating marketplace acceptance, and this is the OCP Marketplace for immersion products. So that what that does is it allows for a rich ecosystem of products to actually be advertised on the OCP website. Our job is to make sure that they're compliant within the requirements stated by that Requirements Revision 2.1 document. So I'm going to focus first on the overhaul of that requirements document. A couple of updates that we really focused on this year. We identified all of our priorities. There's a very diverse group of vendors and users and experts in our community. There's always going to be a laundry list of things that we should be updating our document with. So we had to really narrow down and prioritize. We had about 43 volunteers that participated to help us focus our priorities. And we grouped up the document into different thematic elements to divide and conquer. So certain subject matter experts participated in certain focus groups, others in other focus groups. But in general, what we wanted to do is to create new definitions associated with different technologies that have come online, to clarify some existing definitions, really to broaden the playing field for all current and future technologies that are fit for use to participate. The way that the document previously was written is a little bit limited, very, very specific. We wanted to make sure that we were able to actually introduce new technologies. Some of those new definitions, we wanted to clarify, in this new era of liquid cooling, exactly where does immersion fit? So we created this kind of hierarchy, which I don't think should be too surprising for anyone sitting in this room, but previously it wasn't really very well described in the document. Really setting aside what's in scope and what's out of scope, clarifying which technologies fall under the compliance or the guidance of this requirements document. You'll note specifically for immersion on the left that we're considering the open bath enclosure, the enclosed chassis, and also hybrid styles for both single phase and two phase. This came up in a former session, in the panel session. Our community for requirements and immersion in general is primarily represented by single phase users and vendors. And for that reason, what we often see is an emphasis on that technology in particular in our documentation, in our reports. It's not, though, that this two-phase is out of scope, it's just there's limited participation. So an open invitation to people in the audience here. If you're in the two-phase space and you want to contribute, come talk to me and I can kind of focus your attention, your efforts. One of the really important things that we did was we created definitions for different types of chemistries, different types of fluid families. We actually created new definitions for synthetic and highly refined hydrocarbons, for natural and synthetic esters, for fluorochemical liquids, and for formulated blends. Previously, there was no definition or common descriptor for these fluid types, and if you can imagine all of the oil vendors sitting in a room and agreeing to anything, it's a miracle. We all sat down, it was an incredibly collaborative process, and we came up with a common and harmonized definition of what is in scope according to all of these different families. What that helps us to do as a community is to communicate effectively about what product types we're discussing, what we're selling, what we're buying, what we're using, what we're testing. This is a really important foundational layer that previously hadn't been done. And one of the great things is how many vendors are participating in this community now helped us to make sure that we're approaching the definition in a very open and flexible way. The second thing that we did is we started an overhaul of the mandatory disclosure section of this document. Now, if you have gone through the OCP Marketplace process, the submission process, if you've compared your existing products against this standard here, or this requirements list here, you'll recognize how long it is. There are a lot of tests on this list, and the current version of the document makes them all mandatory. They are all shalls, not shoulds. And so what we've decided to do is to actually implement the approach of common codes and standards bodies by actually saying, you know what, instead of all of these being mandatory, maybe we should consider a mix of mandatory and recommended properties. In some cases, not all of the tests were even broadly available or publicly available to run your fluids. In other cases, we required a lot of data points for properties that we know have linear trends. So what we did is we went in as a team, we provided suggestions on how to update this to make it a little bit more streamlined for vendors, less expensive for vendors, easier to actually comply with, and making sure that we really focused on the fundamental areas where safety would be critical, performance would be critical, or function. I'm going to shift tracks now to a second work stream, the failure mode and effect analysis work stream. This one is a relatively new one in our community, and it's one that's really exciting. It was created out of a fundamental drive to be able to inform compliance and standards and codes bodies with how do we avoid ignition scenarios? What type of flashpoint or auto ignition limit should we apply for products that are introduced in this area? There's a lot of existing documentation for adjacent industries, but not so many for this one. So we focused a lot of our early efforts of the FMEA work on actually assessing the compliance landscape to understand what those hazards were, to actually carry out a high-level FMEA, which is a more bottom-down or bottom-up approach, and then to also look at fault tree analysis, which is more of a top-down approach. What this allowed us to do is to get a better understanding of the ways that the equipment can fail, the relative risk level behind those failures, and the type of safeguards that we might be able to recommend implementing specifically in this application to avoid that failure. So you see here a diagram. This is one of the foundational diagrams that we use to really describe a scenario where ignition might occur. In this scenario, there are two different types of test methods typically recommended. One is flashpoint. That's a scenario where your fluid gets hot, it vaporizes, it hits an ignition source, usually either a spark or a flame, and then you have an ignition event. The second scenario is typically measured or tested by auto-ignition. This is a scenario where fluid hits a very, very hot spot and ignition happens afterwards. So we're focused mostly on those two different types of failure scenarios. During our compliance landscaping and fundamentals overview, what we did is we kind of looked at what is literature in this area and adjacent industries, what is known already for this industry, what's publicly disclosed. This is really, really important for us as a starting point. Coming out with takeaways like auto-ignition and flash don't always correlate. That's really important to understand. Even though they're both looking at ignition scenarios, the scenarios are the criteria that lead to those incidents occurring is very different. That viscosity is related to flash point, but also to performance. That's really critical because if you set a flash point that's too high, what ends up happening is that your fluid viscosity also has to increase and your performance of your system will decrease. I've had quite a few conversations with Michael Sakamoto about this. Insulating fluids like immersion fluids themselves are a safeguard. And so, interrupting or decreasing the performance of the fluid itself unnecessarily can actually lead to a higher risk situation. We also talked about how auto-ignition testing sometimes leads to variability. There's quite a bit of variability that's been observed in our OCP community for auto-ignition testing specifically. So it led to a really rich conversation about, is this the right method? Can we create new methods or adapt the existing method for our needs for this particular type of product? And the last one I already mentioned is that fluids are themselves safeguards. In this compliance overview, what we also talked about was IEC 62368. This is a standard that Kelly mentioned in the industry liaison team. It's also something that Michael mentioned in his recent talk just before mine. What we talked through was how do you define what is normal? How do you define what is abnormal? Where do you set limits and thresholds? And how do the standards bodies actually approach this? Our intent here was to understand, we as experts see the fundamental designs of this equipment. We see the scenarios from largely a equipment or vendor perspective, but that's not how standards and codes bodies always view these things. So how can we speak the same language that they do to provide guidance into these bodies to improve the rigor with which we're assessing our products? The last thing that's ongoing right now, we're looking at a fault tree analysis process. This is a system-level kind of top-down approach, and what it also allows you to do, and it's a little bit different than FMEA, is it allows you to really focus specifically on cascading failures. So this would be a scenario where something occurs, an incident happens, and that leads to a failure elsewhere. So multiple failures in a row. One component fails, then it causes the next component to fail, and that can often lead to a much more significant failure event, a much more hazardous failure event. In that fault tree analysis activity, again, we're focused on ignition. You might be asking why ignition. This is a phenomena that is incredibly important for us. If it occurs, it can lead to quite significant impact, but also it's because our community is limited. We have only so many people. So what we're trying to do here is to focus on one phenomena, ignition, develop our process, develop our internal templates and our internal approach to be able to best communicate out our results. And in this particular one, on this slide, what you can see is an example from this fault tree analysis in which the phenomena is that fluid is not circulating. That's kind of the end state. And you work your way through to understand exactly why, what types of components can fail that lead to that scenario. Ultimately, the outcome here is that we want to be able to provide guidance that has appropriate limits, that has application-specific testing to actually validate for these particular phenomena. And what we want to also do is we want to rationalize, why is it that we're providing this guidance? The work in the requirements group and the work in the FMEA group is highly complementary. we want to make sure that any guidance we put out has some justification. One of the things that we don't have a lot of examples of, actually, is failures. So this is one area where people might get a little bit uncomfortable. They might be uncomfortable talking about failures, but it's really important for us to be brutally honest about where things can go wrong so that in the requirements document, we can then recommend certain safeguards to be implemented. It's a very, very complicated ecosystem. It takes a lot of subject matter experts to participate so that we're reaching the right level of understanding of these systems and also the types of safeguards that can be implemented. So I mentioned that I'd only be able to share updates from the requirements group and from the FMEA group. I also mentioned that I have a couple of other work streams in my technical committee, one focused on power distribution, hardware management, and TCO. These QR codes here will take you to relevant documents for those particular work streams. They have all three of them very important milestones that they've covered in the sessions today. Power distribution is just about to publish their base specification. This is an incredible, incredible milestone for them. The hardware management group, Mick is actually creating interoperability profiles for multiple different cooling environments. This is an incredible amount of effort that's being actually put in across the community to help to actually standardize the way that all of these diverse components interact with each other at the data center level. And the TCO model recently was actually posted onto the OCP Marketplace. They've actually reached a milestone where they're past beta testing and they're now ready to release into the public. So if you actually click on that TCO tool, it'll take you to the current version, but what Andy and Eddie would actually like you to do is to go to the Marketplace, click on the tool there, and to give them feedback on your experience of the tool to make it better. So with that, I want to say thank you. If you're interested in joining any of these work streams or learning more how to participate, come up to me, let me know. If the other work stream leads, if you're in the room, I think you are, could you stand up? Mick is here for hardware management. Adrian's over there for FMEA. I can't see you. Oriel right there for power. And Kevin over here for power as well. So if you have any questions, I think our time is up, but we'll all be here in the room and happy to talk to you. Thank you.